Coming up on today's podcast.
The recent progress in humanoid robots is such that we may well be seeing them as the primary occupant in the kitchen, but also a bit like AI itself. It's not just an app. It's not just a clever box that calls itself an intelligent computer. It's going to be everywhere. It'll be in the fabric of our buildings and everywhere that we see, touch, and generally exist. We currently have 3, 4, 5, 6 companies, I won't go through them all, who are making humanoid robots. They all look pretty similar. I'm sure they're actually internally radically different. But for me, the big question is, beyond the mechanical utility of these things, which is something we'll come back to and talk about the complexity of it, the thing that really interests me is the ghost in the machine, the intelligence that is driving them.
Hello and welcome to another episode of How to Understand Today, your weekly insight into the technology that's shaping our world. I'm Simon Wyndham.
I'm Dave Shapton.
I'm Phil Rhodes.
Today we're going to be talking about robots, whether you see them as the Terminator in waiting or humankind's best friend. We're going to be discussing the latest developments and ask just how far things are going to go. Is Elon Musk going to create an army of Doge cyborgs to take over the world? Or are we going to go more in the direction of Apple's recent cute-looking Luxo Junior-style tabletop lamp? Now, anyone of a certain age will have been used to the rather crap-looking robots that often got presented at trade shows as the future of housekeeping. It was a dream that never materialised, and even now I can't buy a humanoid robot that will have a full-cooked breakfast ready for me when I get out of bed on a morning. Is the promise still real, and is it hyperbolic to be worried about heading towards the universe of iRobot or the Terminator? Dave, are we going to be seeing robots wearing an apron in our kitchens or serving hors d'oeuvres like we were promised in the 1950s, or has our perception of how robotics can integrate into our lives been skewed far too much by science fiction?
Well, I think both of those are true, actually. I think you can hold those two thoughts in your head at the same time. The recent progress in humanoid robots is such that we may well be seeing them as the primary occupant in the kitchen. But also, a bit like AI itself, it's not just an app. It's not just a clever box that calls itself an intelligent computer. It's going to be everywhere. It'll be in the fabric of our buildings and everywhere that we see, touch, and generally exist. So, and the reason that robotics has suddenly come to life is, of course, because of the massive advances in AI that we've seen recently. I think it's worth putting this in perspective, because robotics are, to get a humanoid robot, and let's talk about humanoid robots because they're the ones that everybody loves or is scared of. I think it's, you were talking about the sort of crap robots that we've seen where, they wave their arms around a bit and they've got a red bleeping light on their head and almost completely incapable of doing anything other than, in a rather unseemly way, tripping over the carpet and falling over. And yet, and you might remember, was it 10, 12 years ago, 15 years ago, that Honda had a kind of humanoid robot called, was it Asimo?
Yes.
Do you remember it? And this thing just kind of trundles along. It kind of walked. It even did a really kind of rather limited kind of dance that everybody thought was impressive at the time. Fast forward to today, and you've got humanoid robots that can run, jump, do somersaults, do choreography, and have like fingers with like 27 degrees of freedom. So in other words, they're getting close to the overall functionality, the overall mechanical functionality of a human being. So we currently have 3, 4, 5, 6 companies, I won't go through them all, who are making humanoid robots. They all look pretty similar. I'm sure they're actually internally radically different. But for me, the big question is, beyond the mechanical utility of these things, which is something we'll come back to and talk about the complexity of it. The thing that really interests me is the ghost in the machine, the intelligence that is driving them. And you have to consider this in multiple ways, because it's not just the ability for them to talk to us and understand when we give them commands. It's the ability to control their own body and deal with their senses.
And I guess this is all down to technology convergence, the speed of processors that are available now compared to what we used to have.
Yeah, absolutely right. We would, without the advances in AI, we wouldn't have even come close to this. Although I have to say that Boston Dynamics have been doing some very good stuff for, I think, over a decade. And their original kind of big dog kind of robotic life forms were pretty amazing, not least because they sounded like they had an internal combustion engine. I mean, they were unbelievably noisy. And I assume that is some kind of generator, just because the batteries weren't capable. You know, it would take 3 steps and then stop. But obviously batteries have been improving at the same time. But what was impressive about those early Boston Dynamics machines was that they could self-correct their stance and their posture. So you had these videos that always made me feel a bit uncomfortable in an anthropomorphically motivated way, when somebody would kind of kick one of these robotic dogs and it would stumble and somehow stay on its feet. That kind of autonomic response is so important. And that's hard enough with a quadruped. When you get into the bipedal mode, you have to have incredibly fine control and real time. So I guess the point I'm making is when you're building a robot, you have so many layers and levels of automation that you handle even before you start talking to it or expecting it to interpret the world. So, I mean, going back to the Boston Dynamics thing, they achieved an awful lot with probably very limited AI. And then they were primarily powered, I think, hydraulically, and that kind of reached the limit of its ability, and now they're back to kind of electromechanical models at the same time as improving their, brains, if you like. And the risk of going on too much here, because you can't start on this subject and then stop without covering a whole load of other things. But I'll just mention them briefly, and then we can come back in detail. But first of all, we always thought it would be really hard to be able to talk to a robot. And you can probably remember over generations, and at least a decade or two, of people supposedly talking to robots and just getting a really, robotic response, but not even a good robotic response. It was almost like, do you remember the musical instrument called a mellotron, which was the first ever sampling instrument, and it didn't use computer memory. It used little strips of tape. And when you pressed a key, this tape, which would have like one note of a piano or one note of a flute or a choir, you pressed the key and it would start playing that piece of tape over a playback head. And it could do it kind of polyphonically, because each note had its own strip of tape. Well, when you talk to these robots, it's almost as if they're playing a strip of tape, because their responses were so stilted. And you can imagine a kind of primitive decision tree. Say to it, "How are you?" and it will say, "I'm very well, thank you. How are you today?" But you never got very far with it. You certainly couldn't discuss abstract concepts with them or expect anything like a response that a human would mistake for another human being. Whereas now we have our transformer-based LLMs, these large language models, that are extraordinarily good at conversing with us. Just over the last 6 or 10, 12 months, we've gone, I guess current state of the art is probably the native voice mode in the Chat GPT Pro, which can not only converse almost with no delay, but even put on accents if you want to. So the reason it's called native voice mode is because it's not just a computer voice reading some texts. It is actually generating the voice in real time to satisfy the conditions that or the parameters you've given it. So you might might say to, right, read me the shipping forecast in a Northern Irish accent, and it will do it. So given that, that's one enormous problem of communicating with robots that's been solved.
Yeah, I mean, on that, it is quite good when ChatGPT does that. Although it does have a propensity to get stuck in an Indian accent. Yes, the politically correct brigade will not be happy with it. I once asked it to say something in Welsh, and it did so initially. But then for some reason it went into an Indian accent and wouldn't leave it, even when I told it to go back to an English one. Anyway, Phil, what is your sort of opinion on all this?
I mean, I guess in my brain, this breaks down into two things. This breaks down into the AI part of it, and it breaks down into the mechanical engineering part of it. And I think the AI part of it is kind of fairly well covered. And I think you can train an AI to walk a robot exoskeleton around. That's no problem, or at least it's a more solvable problem than it ever would have been. So the mechanical engineering part of it is the part of it that's interesting to me, particularly because it starts hitting some quite fundamental problems. I mean, for a start, not problems, but challenges. The first part of it being, well, what do you want this robot to do? And when people say robot, they think, the Terminator, it's a humanoid. But the only reason you would make a humanoid robot is if you wanted it to be able to do all the things a human can do. In which case you're aiming to make a very general robot, which is going to need an extremely general AI that can deal with a huge range of things. Otherwise, it's not useful. If you want it to do anything more specific than that, if you want it to hoover the carpet, you don't make something to push the hoover around. You make the little spherical, cylindrical thing that buzzes around on the floor, and that's a robot and that does that job. The only reason you want to make a humanoid one is if for some reason you want it to be able to interface with all the things that humans interface with, which is what you need if you want a general, household help or whatever, but is not the case if you want anything more specific than that. And the challenges of it, and which comes back to what we were saying about the sort of internal combustion engine noises, are that human beings and the motions that we can make have they have a combination of speed, precision, and power that are actually quite difficult to build. And one of the places that we see this is in some of the Disney theme park rides. There's a Disney theme park ride which is based on the Avatar film, which has an avatar with it's a large humanoid thing. And it moves like you would expect it to move. But to do that, they're using the very zenith of industrial robotic technology, which has to be plugged into a very large power supply. Because to do, this with your arm, my arm's moving quite fast and my arm weighs a few pounds. And, the reason I say this is because I have at least some small background in building little props and things for film and TV work sometimes, increasingly historic now, but I do. And one of the things that you frequently see in that sort of what you might call a light industrial environment is pneumatics, because pneumatics can generate quite a lot of power. We would build pneumatic devices that would have little CO2 cylinders in them to run them. And you'd run your CO2 cylinder out really pretty quickly. If you have a CO2 cylinder and a pneumatic actuator that can actuate over, say, 50 millimeters, 100 millimeters, and with a few tens of pounds of force, you will only get 20, 30, 40 activations out of something like that before you've emptied your little CO2 cylinder. And this is why these things sometimes have ended up with internal combustion engines on them, because people go, oh, I'll use batteries. The problem there is the same problem we have in electric cars. Over the last 20, 30 years, battery prices have come down and things have improved a lot. Absolute battery capacity has improved, But if you look at a graph of computer horsepower over that time, it's an exponential curve because of more. And then you look at memory capacity, and it's slightly flatter, but an exponential curve. And you look at storage capacity, there's still an exponential curve. You look at batteries, and it's kind of
flat.
It's not quite flat, but it's not great, which is why electric cars are still, in terms of range, compared to an internal combustion engine car, not great. And building what you want, building Mr. Data from Star Trek, what does he run on? That's like one of the big mechanical engineering problems, because he's very strong. He's stronger than a human being. He's very fast. He can do all the things that we can do with the speed and the precision more than us. What does he run on? What does Ash in Alien run on?
He's also 400 years in the future. But
this is the thing,
But you said something interesting there, Phil, which I think is really important. And you were saying, why build a humanoid robot to move a vacuum cleaner or trundle with a wheelbarrow? But what we're talking about is that, in a really non-trivial way, is the difference between a specialist tool and a general purpose tool.
Yeah.
So, like, a calculator is a niche tool. It's a pocket calculator. A computer is a general purpose tool. And I think you're sort of AI Roomba type robot is a specific kind of niche thing, whereas the entire raison d'etre of a robot is that it's a general purpose tool. And so, yes, it can do all of those, but probably at 20 or 50 times the cost. But I just wanted to say, so you can't go very far into a conversation about robots without talking something which sounds like horrendously technical, but is like crucial and can be easily explained with AI and robots. And that is that imagine that AI at the moment, without hands, feet, head, eyes, ears, senses, touch, and so on, it's essentially a brain in a vat of oil. It's functioning, but it has no connection with the outside world. And that severely limits not only its ability to learn, but its ability to understand stuff at all about the world. Now, the big sort of generative, in the sense of being open-ended and massive, the big generative step that you get when you put your disembodied AI brain, and it's not a brain, of course, it's a computer, but when you put it inside a robot, just imagine the difference you've got there, because you're not now restricted to training it in a sort of data center way. You train it by letting it wander around and find out. Sorry, I was just finish this bit. So by the time it can, see something and like wonder, what's that? What's that orange light over there? And what's that thing? Oh, it's a flower. I've heard of those, but I'm going to go and walk around it. I'm going to touch it. Oh, the petals have fallen off. And all of a sudden you have a robot which is not just learning about stuff, it's learning about it in the world, its place in the world. And that is like that's analogous. You've heard of there was a lady from about, I think probably 100 years ago, called Helen Keller, who was both blind and deaf. And, 100 years ago, sorry, I don't know the exact dates, that was a recipe for a pretty miserable and limited life, because you just couldn't learn. You couldn't communicate, you couldn't learn. You just exist on a level, but your idea of the world would be extremely limited because you couldn't go beyond your internal thoughts and your sensations. So you'd be limited, for example, to thinking hunger. You wouldn't be thinking I am hungry. You'd just be thinking hunger, because you haven't even got the ability to self-identify. And you don't need to talk about I if you're not aware of the world out there. You don't have to distinguish yourself from the outside world. So, but what happened was that people started to communicate with her they taught her an alphabet. Then they taught her the meaning of the words by just touching her hand. And through that, she said she suddenly had a realization that the world wasn't just internal to her. There was a world out there, and she existed in contraposition to the world. And that might not sound like a big deal, but it is the biggest of deals. It's realizing that it's not just you, it's you and the world and other people and language and everything. And when you put an AI into a fully functional robot, and it's called Embodiment. It's been known about for some time now that to get a truly great functioning learning AI that understands the world, it needs to be embodied. It needs to have a body. It needs to have eyes and ears and senses. And sorry, I'm going to stop in a minute. But if that wasn't profound enough, we all have to go to school because we can't learn by someone else going to school for us. But robots will all be connected, so they can all learn collectively. So they'll learn millions of times faster than us.
Yeah. So just Phil, just want to interject, Phil. Just to go back to your points on, and this kind of plays into a bit about how we think about robots. Now, Phil, you mentioned about the hydraulics powering the limbs, which brought up memories for me of the very famous hissing Sid demonstration on Tomorrow's World once, which went very, very wrong. It's worth looking that up on YouTube if you haven't seen it. But one of the things or aspects of research that is going on at the moment is into how to develop a functioning artificial muscle, a flexible muscle that can control limbs and therefore make a much more humanoid style robot. Now, the materials to do this, they're proving problematic to do in any sort of scale. They can do it on a microscopic scale, which actually has side benefits for medical robots, ones that can go inside the body and they can change shape as they maneuver through the arteries and unblock things and that sort of thing. And there's a lot of research going on there, and they've done simulations. They've had an AI control this particular robot having to fit through different gaps, and it changes shape to adapt to the situation. So, we often think about about robots as being humanoid or being like something from Short Circuit or the Terminator or whatever. But actually, a massive amount of research and development is going on in terms of microscopic robots that can really, really help from a sort of medical point of view.
Everything from a moving light in a nightclub in the late 90s is a robot, an industrial robot, which comes back to what we were saying about them being task specific. Something that Dave said made me think about something about these things all being interconnected. I mean, once here again, coming in with my jug of cold water. For right now, they're going to have to be, because one of the most power-hungry things you could put in a modern robot would be a neural network. Yes, there's lots of work going on with truncation and quantization and compression and all kinds of things. Right now, it's hundreds and hundreds of watts to run a decent AI, and anything like a real-time manner as well gets really, really difficult. You're not going to chuck a GPU in the back of a robot because that's going to pull half a kilowatt, and again, what's it going to run on? So is the brain of this thing going to be in it? But even beyond that, when we're talking about them learning, I mean, this is, again, becomes much more a thing about AI than it is about robots in particular. But an AI can learn by looking at the world through things that aren't part of what we might identify as a robot. It can look through cameras, it can listen to microphones, it can do all those things without necessarily having a body. The question is, do you want this thing to become a human being? Do you want it to learn what it's like to be a human being, philosophically? And how would you tell? How would you be able to prove the fact that, what does it feel like to be in that body? I don't know what it feels like to be in another human being's body, let alone some robot body. So how do you even prove that? Some philosophical stuff that gets quite interesting as well.
But I mean, that sort of plays into how we respond to robots. And I think this is why the Apple Luxo Junior lamp style thing that was unveiled this week is quite an interesting one, because one of the things that they're doing with it is they're experimenting with how this robot can exhibit character, even though it's just a lamp.
Yeah.
Just like the Pixar animation. So it's doing stuff like, if you ask it what the weather is like, it will glance out of the window and then look back at you.
Yes.
Yeah, well, it may be, but the whole point is to kind of create an emotional connection with it, even though it's just a lamp. And how we relate to robots is going to be quite important, I think, in terms of making humanoid robots.
I think all of which is kind of circling the question of can a robot be conscious, and what would it mean if it were? Well, we won't deal with that today, because that's a whole separate conversation. And I think what you're just saying, Simon, the sort of anthropomorphism is actually very important. But all I was going to say is that, so let's imagine we've got, the Turing test. You remember the Turing test? So I think there are various definitions, but the core of it is that if you can have a conversation with a computer and not realize or not be able to distinguish it from a human being in a blind test, then you have to say that to some extent that is artificial intelligence. Well, in many ways, we're way past that now, especially somebody who's not familiar with the latest developments in AI. And in fact, Ray Kurzweil made the rather important point that in order to pass a Turing test these days, you'd have to dumb it down. Because otherwise you'd be asking your subject, your experimental subject, what's your favorite poem, and it will read you the entire works of Shakespeare from memory, and probably do it in whatever accent you ask it to do it in. But I think here's a philosophical thought experiment, which is, if a robot, it doesn't have to look like a human being, but if a robot could behave exactly the same as a conscious being would, in every way, how would you know? How could you tell it was not conscious, or would you know it was conscious or not? Is that sufficient cause to say that it is conscious if it behaves exactly as if you would expect a conscious entity to behave?
Well, that's going to cause some very interesting moral dilemmas, if anything gets to that stage, if we're talking about robots being sent into battle. The military is obviously very interested in robotics. And as you alluded to earlier, Dave, this idea of connected learning. So, everything's feeding into everything else. It might sound hyperbolic, but is it really to question the idea of effectively a real life Skynet stroke Terminator style scenario coming into being?
Completely reasonable. I mean, and this is the thing. None of this requires robots either. I mean, a lot of these are questions about AI in general, whether or not it's applied to robots. Assuming this thing is fully autonomous and self-sufficient. I mean, it is actually addressed in the Terminator movies. What do these things run on? Well, fusion power, of course, because it was the 90s. But assuming you can't run them out of batteries, then, I mean, I think one of the most terrifying things, I actually discussed this with a colleague of mine about a science fiction script we were working on. That what's the scariest thing you can imagine being a robot? Okay, big shiny steel skeletons, they've been done. And then we looked at this bit of footage of an AI flying racing drones. And we thought, well, if an AI decided to run that drone into you, it would, and you would not stop it, assuming that you couldn't dive into a vehicle or something. We've seen this in Ukraine recently. When you arm these things, they are horrifyingly effective. An AI could run that thing into you. If you were caught in the open, it would get you, and there would be nothing you could do about it. If it wanted to avoid being shot at, it could, and it would be very hard to avoid. AI safety, again, this is an AI thing, not a robotics thing, but AI safety is a real field and a real field of research, and that's absolutely something we're aware of. I hope we're aware of it enough, and I do wonder that sometimes the companies who want to make a living, which is completely reasonable, will prioritize making a living over making a living safely, which is not an unprecedented concern and is not something we haven't had problems with in the past. If you make it fully autonomous, then it's very hard to shut down potentially. If it's a racing drone, the racing drone doesn't have the AI on it, so you can go to wherever the AI is and unplug it, and that's, there's solutions to that. But in extremis, if you can get these things to be, self-sufficient, which is being talked about in terms of autonomous aircraft, certainly, that's a robot. It's not a humanoid robot. It's an aircraft-shaped robot. It looks like a fighter jet. In fact, the ones that I think are being developed here in the UK, a project called Tyrannus, is designed to be run either crewed or uncrewed. So it has a cockpit and a seat. And if you're a military project, then you really don't want the thing to be messed with externally, because people will try to. So what are you running the system on board? Are you running the AI on board this thing? In a jet fighter, a few hundred watts isn't a problem. You've got that much power available to you. Is that okay? This thing is autonomous. It can go wrong. A Terminator scenario is entirely possible. I mean, yes. And certainly to the extent that if people are not taking that seriously, then that's worrying.
And I think if you look at the rate of change just over the last year, especially with robotics, it is accelerating. It is inevitably accelerating. And I think, so it's very hard to extrapolate from where we are now to where we will be even in 6 months. Never mind 6 years. But I think, we brought up the question of will it have the AI on board? I think it'll have some AI on board. But it will mostly have recourse to AI in the cloud, as indeed we will when our brains start to essentially treat cloud-based AI as a brain prosthetic. So, one of the most interesting areas of research is the brain-computer interface, and again, that's seeing progress. And just like with the early MRI scans, they're pretty low resolution, but the resolution is increasing all the time. And again, that's an exponential thing. You only have to double the linear resolution to have 4 times the amount of data, and probably another order on top of that in terms of its usefulness and interpretability. So we're very much in a virtuous circle at the moment with all of these technologies, but I think robots will be transformative because they'll be out there in the world. I just want to say, not to put a damper on the robot thing, but just to ram home how far they've come. People that have never met me probably wouldn't know that I actually have 2 prosthetic legs. I was born with both legs missing above the knee. So I'm very lucky to have 2 so-called robotic knees. Are they really robotic? Arguably, but arguably not. Depends on the context. Do they propel me forward? No, they don't. What they do is they control what's called the swing phase, which is when you take a step and without any control, your lower leg would act a bit like a pendulum. It would have a fixed rate of swing, which is great if that's the speed you want to walk at, but it's no good if you want to go faster or slower. So these things electronically control fluid-based, or in other words, hydraulic dampers to control the ballistics of the step you take. And it's pretty effective, but it's a tiny, tiny, tiny part of an entire humanoid robot. It doesn't even propel you forward. It just has a very small battery that controls a few valves that can use this fluid to damp your movements and to overall make it more efficient. And it's fantastic and actually very expensive. Luckily for me, provided by our National Health Service. And of course, I got 2 of them. But so to me, that just illustrates how incredibly advanced the current generation of humanoid robots are. And in fact, you're probably used to seeing, I think the Tesla Optimus robot still walks like it has some kind of chronic constipation. It's.
I don't understand why it's so bad, given that other robotics developers have made much better ones. I mean, I see it this year. The Beijing half marathon is opening up entries alongside humans to the various robotics companies around the world.
Yeah, what's really interesting about that, these robots that walk with a much more natural gait, as in GAIT, their legs are much more akin to human legs, in that they'll take a step and the lower part will swing forward and then it will lock, and then they put their weight on it and it will be straight. It's none of this kind of bow-legged kind of action. The reason they've adopted the kind of bow-legged stance is because it's easier and quicker to make unexpected movements, but it's very inefficient for walking. Whereas the latest Japanese, the unitary robots, you've seen them running and walking with a very natural gait, and they have the kind of locking knee, but still manage to be incredibly responsive. So it's like almost every week we're seeing a major breakthrough in the mobility of robots.
I mean, I think, with the ultimate conclusion, as I was talking about earlier, in terms of organic artificial muscles, and you mentioned the interfacing of sort of electronics with the human brain and everything and stuff like that. Well, if we take this to its kind of logical conclusion, we are really talking about something akin to Bishop in the Aliens films, really, an artificial human life form. And then obviously the moral quandaries become very much like the movies. And in terms of space exploration, what would you rather send out into space to go and explore? You would send something like Bishop, because he doesn't age. He can go as far as you want.
But the thing is, you talk about something like that and you go, well, why would you send that? When we sent robots into space to explore already, why would you send something humanoid? Well, the only reason you would do that is because you have an expectation of its ability to explore places being based on the ability of a human to explore places. And it's frustrating that these rovers they have on Mars are frustrating. They're slow. They have to be programmed. Every wheel turn they take has to be planned hours in advance and sent up and carefully executed. Partly that's because of the time delay in transmission reception, but the reason you would send Bishop out is because you wanted something humanoid, because you wanted to have a human-style ability to explore. But that might not be the best way.
Or to interact with other humans.
Well, possibly, but then, that does it become weird? There are all these questions like, should you do that? And how would that be? And people make movies about that. And that's, that's where you get Ex Machina and so forth. But yeah, it's interesting.
Yeah, well, I mean, just drawing all of these threads together, and really the main thread is again exponential progress. So I think if we look back at this episode in 6 months, it'll be like, well, they what they're talking about is prehistoric, it's the network ability of these things, even though they're mechanical, their ability to share information about what they've discovered about the world. And That's in parallel with the fact that a lot of the work NVIDIA is doing at the moment, and other companies, is building virtual worlds within which to train robots. And because they're virtual, they can run millions of those in parallel.
Yeah. I mean, this is clearly a topic that we're going to be returning to at some point, because there is a lot to discuss, and there are probably some very specific areas that we can go into as well. So I think we'll leave it there for now. Phil, you need to get off quite clearly. So yeah, we'll leave it there, and we will reconvene for next week's episode. So thank you very much, guys, and we'll speak next week.
Yep. See you. Bye.